Hey students, in this video I'm going to just explain about transformations of functions. Here we have some samples of quadratic functions showing the different transformations that can happen. You can have a parabola and a quadratic function reflect over the x-axis, sometimes also over the y-axis. You can also have a quadratic function dilate, which means change in size. So it can become smaller or thinner or narrower or also wider. But in this Algebra 2 level, we are going to use specific vocabulary, and we're going to use vertically stretched, vertically compressed, horizontally compressed, or horizontally stretched. The other transformation that can happen is a translation, which means we can change the location of where that parabola is at. So we can shift it up, shift it down, shift it left, or shift it right. In class, I explained how the template for a transformation technically has all these letters right here, A, B, H, and K. Those four letters are the ones you can manipulate with different numbers in order to change the transformations of any function, actually, not just parabolas. So what you need to remember is what each one does. So for example, we talked about A and B being the two variables or values that actually change the dilation, the size. We can stretch it or compress it. You just need to know which one does what. So the A value is the one that does the vertical change, and B value is the one that does the horizontal change. So you're going to have to just describe if it's stretched or compressed. Okay, and then when we talk also about A and B values, we have to understand that A and B can also do the reflection if it's negative. So on this box below, I'm going to write if it's negative, then it will reflect. Now, how does it reflect? That's where you need to remember which one does what. So the A value specifically does the reflection over the x-axis. And the B value right here will do the reflection over the y-axis. We also explained how H and K are technically any variable could replace this. Usually it's C and D, that's why it follows A, B, C, and D. But these notes have H and K to remind you that the vertex is usually seen as H, comma K. And the vertex could be found with these two letters right here, H and K. And what H does is that it shifts, so it does a translation. It shifts the graph left and right. So shifts left or right. And the K does the shifting up and down. So those of you who are visual, up will be, of course, up, and then down, and then left or right. You need to remember, though, that whenever we replace the H value, we are only replacing this, the H, not the minus. So you always have to have that template in mind, that is X minus an H value. Also, keep in mind that B is located after the function, after the F, inside a parentheses. But in between that B and that X, there's also another parentheses. So just keep that in mind for future reference. So on your notes, you do have here a table that has everything summarized, but of course this is meaningless unless you understand what each variable does to the graph when you change it. So let's do a couple of examples. I'm going to go over the examples on the left side, and that way in class you can practice the ones on the right side. You can always pause this video and do them and just check to see if you can do them correctly. So first of all, in class, I advise you, whenever you're given a graph, you need to recognize the parent function. So anything that has usually f of x, that is your parent function. I advise you guys to highlight it just so you can obviously see it. And then I next you kind of just look at it and ask yourself what happened to it. Here you can tell that this graph, it used to start 0 and go to the right. And now it is down here at -4 on the y-axis, and it seems to be going to the left. So it definitely looks like it reflected over. So I'm just going to show the paper. It reflected over the y like this. And when it reflects over the y, it's going to tend to look this way now. But then in order to look that it's down here, that means we moved it down. So the transformations that happen here is that it reflected over the y-axis, and it shifted down 4 units. So again, this is the origin, and now it's at -4, so that's how it shifted down 4 units. Now, how do you write the transformation in a function notation? You will have to remember the template, which once again, it's in the front, this whole thing right here, a f b x minus h plus k. So I'm going to write that down. A f parentheses b parentheses x minus h plus k. And if it reflected over the y-axis, based on the descriptions I've given you before, we talked about reflecting over the y-axis was the b value. So we're going to have the b value be the one showing that. And then the shifting down 4 units, we talked about the k value being the one that shifts down. So k is also going to be affected. So to write the notation for this, we're going to have nothing for the a, because nothing happened that affected the a value. We're going to write down f parentheses. That b value, in order to show that it reflects over the y, we're going to put negative. And then we have the x. There's no h value, so we can just ignore that. And then the k value is shifting down 4 units, so we're going to put -4. So this notation right here is what shows that transformation on that graph. So let's try that again. By the way, if you want to check in the calculator, you can always do that. But you don't know what the parent function for that is to type it in. So therefore, it's not really helpful. You don't know yet what that equation is. So let's just not use the calculator in this case. Let's just stick to the parent function, the template, I guess, that affects the functions that you have. All right, let's try the next one. So here we have a function that goes from left to right, going up. And then now the new one, it's from left to right going down. So it definitely reflected over the the x axis. So it just flipped over like this. And if it flipped over, it would look like it's down here. But then now if you notice the one we're looking at, it's actually shifting this graph up. So it's going to be reflect over x-axis and shift up 1 unit. So again, rewind or pause the video if you need to see that of how this happened. So then we start with the template of transformations. That's a f parentheses b parentheses x minus h parentheses plus k. And then now we're going to highlight, or I'm going to highlight, the letters that were affected by these transformations. So reflect over the x. Over the x, we talked about being the a value. So if a is negative, that's reflection over the x. And then shifting up 1 unit. So that k is the shifting up and down. So that's the one that's affected. We are not using the b or the h. So we're just going to write function notation of the transformation by putting a negative on the front of the f. The x stays the same because there's nothing to it. and then up 1 unit, so plus 1. So this is how we will have the notation for that second problem. All right, on the next two problems, we don't have graphs, we just have transformations. So this is the ones that you can use a calculator by assigning a graph yourself or just practicing the template that, again, you have on your notes right here. If you are visual, of course, using the calculator helps. So we're going to look at the template under the new transformation that they're asking you to do. So that's A, F, B, X minus H plus K. And from the numbers that I have here, it looks like the 5 belongs to the K and the 6 belongs to the H. And that means that we are not using A and B at all. And we could either look at our notes and know that H is the left to right transformation and K is the up and down transformation. So we know that this is affecting it by shifting it left and right or up and down. To be specific, we need to just visualize it. So you need to look at f of x and pick a parent function that you want to use to graph. And it could be anything. For example, f of x equals x. That is the linear parent function. F of x equals x squared. That's the parent quadratic function. Then we can use any other, for example, one that I taught you recently was the absolute value. So we can put absolute value of x. And there is the parent absolute value. So let's try that one just because that's what we're reviewing. We are going to now type this transformation to that. So it's going to be f parentheses x minus 6 plus 5. And if I press enter, nothing's going to happen, partially because f by itself is not reading anything. The calculator doesn't know what to do with that f. You are trying to tell the calculator that you want the parent function to be transformed. The parent function right now is labeled as f of 1, so you need to type f1 in here. So now it's recognizing that the parent function will be transformed by those numbers. Press enter, and now you can see that it graphed it over here. So specifically, the numbers that we are using, 6 and 5, we know that 6 is to the left or right. Definitely it moved to the right. So we're going to say that it shifted right 6 units. And then definitely went up. So we're going to say and up 5 units. So that's this description for this transformation. On the next example, we're going to stick to using this as a parent function just for practice. And we are now going to write down this transformation. So before I graph it, I want to write down the template, AF, B, X minus H plus K. Okay, and then now I can see that the letters that are affected is that 2 with the B value and that 4 with the H value. So I'm not going to describe anything about the A or the K. All right, so now I'm going to press tab and edit that transformation that I had typed before and type the new one. So we're going to type F1 parentheses 2 parentheses x plus 4 and close it and press enter. So here is the new graph and we need to describe that. So again, if you look at the notes in the front, we are talking about B value. B value affects it horizontally and H value affected by shifting it left or right. So this graph definitely shifted left. So as far as how much it shifted, that's where that 4 comes in. It shifted left. 4 units. And then now that 2, we need to talk about what that 2 did. So definitely in class, I explained how a rubber band can visualize what are we going to do with it. Remember the B value, once again, is a horizontal change. So we need to write down if it's a stretch or compress. So if I align this rubber band to the blue one, and then all of a sudden I compare it to the red one, I'm going to notice that the red one is on the inside. So I'm going to have to horizontally, I'm going to be pushing it in to make it look like that. So that means that horizontally I'm compressing it. Also, what you can do is double click your calculator and erase that 4, because you already know that the 4 is shifting it to the left. So now if I press enter without the 4, you can definitely see that that 2 is making it thinner, which is making the graph or the function be pushed in. So horizontally, I'm compressing. So what I'm going to do now is write down a horizontal compression. So horizontally compressed. And you need to specify by a scale factor of, and if it's a B value, you have to say 1 over B. If it's an A value, it's just by a factor of A. But if it's a factor of B, it's 1 over B. So horizontally compressed by a factor of 1 over, and then the B value is a 2. So 1 over 2. And that's the description for that problem. All right, the last problem here is g of x equals 2/3 f negative x plus 7. So I'm going to grab the calculator and edit. And again, if you don't have a calculator at home, you can always use Desmos online. Desmos graphing calculator. And then here I'm going to type control divide 2/3 f1 negative x plus 7. So if I don't see it, and I know I typed it, and I know I typed F1, let me verify to make sure I typed F1. I did. The only other option is to zoom out, because it has to be there. So if I go to zoom out, there it is. I clicked and I zoomed out, and there it is. So definitely it shifted up. So if I write the template of the transformations underneath, I'm going to have A, F, B, x minus h plus k. And the transformations that were affected was the A value with that 2/3, a B value with that negative, and then that 7 is on the outside of the parentheses. So I'm going to put it in plus k. So that up, shifting up, was that 7. And then I'm going to now look at my notes and remember that A is a vertical stretch or compression. So I need to describe what that 2/3 did. And then the B, when B is negative, it will reflect over the y-axis. So I can't really see this being reflected over the y-axis, but if I was to change my parent function into another type of function, for example, let me show you. I'm going to change the parent function to x to the 3rd power, because that's another function you're going to learn about later. But with this one, you could tell that it reflected over the y-axis. You could tell the blue one is going up from left to right, and then now the red one is going down from left to right. So that shows that it just flipped upside down. I mean, sideways, sorry. So that B value, it's a reflection or reflected over y-axis. And then the last part is describing what that 2/3 does. So I'm going to switch back to absolute value. And then what I'm going to do now is on the red one, delete the 7, because I already know it shifted up 7. And I'm going to delete that negative because I already know it reflected over the y. And now I press enter, and this is what the 2/3 does. It definitely makes the blue graph become wider, which means now I have to describe that with the word vertically because A is the one that's affected, so vertically. So if I have a rubber band, how can I make this rubber band be vertically wider? So do I stretch it or do I compress it? So definitely compressing it will make it wider. So it's going to be a vertical compression or vertically compressed by scale factor of, and then once again, you look at your notes. When it's a vertical stretch or compression, you just say by a factor of A, whatever your A value is. So A is 2/3 by a scale factor of 2/3. All right, so those are the examples I went over in the notes. I hope you guys take the time to do the practice on the right side. Let me know if you have any questions, and I hope this video helps.